We are moving on to our next unit. So we're going to be talking more about triangles today. We're going to learn more theorems about triangles. We already know some things about triangles. We know a lot about congruent triangles. We know the angles inside a triangle add up to 180 degrees. We know if you have an exterior angle and angle outside, then the two remote interior add to equal the exterior angle. But today we're going to start with just what kinds of side lengths can actually make a triangle. So if I were to start drawing a triangle, let's say I've drawn this side length of a triangle. I'm going to estimate it's about 10 inches. Well, what other side lengths could I have so that I actually make a triangle? Let's say I use this side length and I only make it 2 inches. I do this side length and I make it 4 inches. Well, we have a problem with that. I can't actually make a triangle with side lengths of 2 inches, 4 inches, and 10 inches because the 2 and the 4, there's no way they can connect to the ends of the 10 inches and connect to each other. So we have something called the triangle inequality theorem that lets us know what side lengths could we actually use for a triangle. So the triangle inequality theorem states any two side lengths added together should be bigger than the third side. So a little more mathematically, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So for example, let's see if we can figure out if three numbers can actually make a triangle. So let's say we have 8, 12, and 17. So according to the triangle inequality theorem, any two sides I add together should be bigger than the third. If that doesn't work out, then we can't make a triangle with these. So I pick any two sides and I add them together. Let's take the first two. 8 plus 12 is 20. So we have to say, well, is 20 bigger than 17? Because 17 was the third side. It was, so that was good for us. But then we have to check all the other sides. What about 12 plus 17? 12 plus 17 is 29. The third side was 8, and 29 is bigger than 8. So we've done 8 and 12, 12 and 17. What about 8 and 17? Give me 25. That is also bigger than the third side of 12. So this checks out. We can make a triangle. If I had, for example, 1, 10, and 12, I can try and add those first two together. 1 plus 10 is 11, but 11 is less than that third side. We don't like that. That doesn't make a triangle. So no, we couldn't make a triangle with those three sides. Along with the triangle inequality theorem, we also know that in a triangle, that the longest sides match with the longest angles, and the shortest sides match with the shortest angles. I don't believe this has a theorem name, at least not that I know of, but we'll still write down what we're meaning. So in any triangle, the largest angle matches with the longest side. And that side is across from the angle. So let's look at a triangle, and I'm going to give you a triangle where we have all the angles labeled. We're going to try and find the largest sides. So we're going to order the sides from least to greatest. Triangle XYZ, and I know this angle is 22 degrees, this angle is 137 degrees, which means the last angle must be 159, 21 degrees, because all those angles have to add to be 180. So if we're going to order the sides from least to greatest, we first identify the smallest angle. 21 degrees is our smallest angle. So when we say that the sides match to the smallest angles, the largest side matches to the largest angle, and the smallest side matches to the smallest angle, we're meaning the sides across. We look across to the side that wouldn't touch our angle symbol. So that means the smallest side is from X to Y. We're ordering from least to greatest. So now we look for the medium-sized angle. That's 22 degrees. 22 degrees is the next angle up. And we also look for the side across from that angle. That means side YZ would be the next biggest side. And then the greatest side would go with the greatest angle. The greatest angle is 137. The side across from it is XZ. So the largest angle always goes with the largest side, or vice versa. I could give you the sides, and you could order the angles from least to greatest, or greatest to least. We can also talk about, so our last thing about triangles today, our last new theorem, is going to be the triangle the mid-segment theorem. So looking at my triangle inequality theorem again, but we're going to talk about the mid-segment theorem next. That's this theorem. R looks like an N because I merged it with my E. Theorem. So the mid-segment theorem states the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long. So let's draw a triangle and see what we mean by this. Okay, here's my triangle. Let's label it ABC. We use quite a bit to label our triangles. And we want to pick the midpoint of two sides, any two sides. So I'm going to pick the midpoint of AC, halfway between A and C. Oops, sorry, I meant that to be a marker. There we go. It's about there. Without a measurement tool, we're just estimating right now, but we can estimate where that midpoint is. Then we're going to look at AB and also look for the midpoint. So we're going to estimate approximately where the midpoint is. I might even bring mine this way a little bit. So I'm making marks. If that's the midpoint, then we know either side of that midpoint is the same length, because the point of picking a midpoint is so that from A to the dot in the middle, and from C to the dot in the middle, those two lengths are the same. That's why it's a midpoint. So if we connect those two midpoints, then, by definition, that line is actually parallel to the line that doesn't have a midpoint on it. And it must be every time. If instead of going from the midpoint of AB to the midpoint of AC, if I had done the midpoint on the bottom of our triangle, what we got would still be parallel to the third side. So those are parallel. And then the segment in the middle is half as large as the bottom segment. So if the bottom segment was 10, this segment in the middle would be 5. And again, that must be the case every single time. So we can use that information to solve some problems with our triangles. Say we have this triangle. Let's label it M, N, O, P, Q. Let's say we know from N to P is 12 inches or centimeters. If I don't label it, then we don't really have units. That's okay, we can still solve for MQ. So with this picture, I would say find MQ. Well, we know that NP is a mid-segment. Remember, that's the name for this line in the triangle. It's a mid-segment because they put these marks on either side showing those two sides are the same and showing these two sides are the same. So from M to N and N to O, those are congruent. So we know it's a mid-segment, and we know that parallel side is twice as big as the mid-segment, or the mid-segment is half as big as the parallel side. In other words, all we need to do is take that 12 and multiply by 2. So MQ would be 24. If I took that same picture, and instead of giving you the inside length, and this time I'm not going to label the MN and all that, if I said the outside length was 30, I could go find the inside length by dividing by 2. 30 divided by 2 would give me 15. So if I'm just asking you to find the length of the side, that's pretty easy. But a lot of the time we have got to be able to set up equations for these types of problems. So let's say I know the inside mid-segment is 2x minus 1. And I know the outside length of the line that's parallel is 6x plus 10. So I want to be able to set up an equation in order to solve for x. Our goal here is to solve for x. So when we knew that inside information, if we look at our last example really quick, we knew that inside information was 12. To find that outside length, we had to multiply by 2. So we took the inside times by 2 and we got the outside. Well, it's easier for us to work with multiplication than division, so even though I could say, well, outside divided by 2 is the inside, I'd rather pick the multiplication one, even though both are true, because multiplication is easier for me to work with. So I want to use the inside information times 2, and I know it equals the outside information. So inside we have 2x minus 1. Now we have an entire expression, so I'm going to have to put it in parentheses if I'm going to multiply by 2. And we know it equals the outside information. The outside information is 6x plus 10. So now I have an equation. Once we have an equation, we just have to be able to solve this equation. So if I'm going to solve this equation, we have to get rid of the parentheses first. So we have to think to ourselves, how do we get rid of parentheses? Hopefully you thought, well, I need to multiply. But we can't just multiply the 2 by one of the numbers. We have to multiply it by both. So we distribute. So we multiply 2 times everything. 2 times 2x is 4x. 2 times negative 1 is negative 2. We haven't done anything on the other side yet. And now we've finished by solving this equation just like we would, and we've practiced solving equations quite a bit. So first I have to combine my x's, but they're on opposite sides, so I'm going to have to use opposite operations. Minus 4x from both sides. And I've got to get all my numbers together, so I minus 10x from both sides. Not 10x, sorry, minus 10 from both sides. We get negative 12 equals 2x, and then divide both sides by 2. So we get x equals negative 6. Now I did make this problem up randomly, which sometimes leads to values that don't actually work. If we tried to plug x back in, we'd get negative lengths. So that was my error, not because this problem was done incorrectly. We went through the correct process, so we know how to solve them, just my original equations weren't ones that could actually be solved for. But on the homework, that won't happen. It was just because I made up a random problem for the notes. So I hope you enjoy your 4-day weekend, or that you have enjoyed your 4-day weekend by the time you're watching this. And I will see you guys on Tuesday.